In this video, we're going to explore what happens to the particles and the energy when we heat a solid and then a liquid and then a gas. So when we're putting something through its three primary phases or states of matter. So it doesn't matter what the solid is. It could be water, it could be wax, anything. When we heat something, we're adding heat energy to it. That energy has to go somewhere. So what happens is that in the solid state, which is what we're looking at, starting with solid, we would have that energy being converted into kinetic energy. So the particles move a little bit more. So these dots are going to represent my solid. And as I add heat energy, they're going to move more. And in doing so, they're going to move further apart. That increased kinetic energy on average of all the particles results in a temperature increase. So capital T is temperature. What I'm doing here is I'm adding heat energy throughout this. I'm not stopping at any stage. So the particles expand. And that's what we see here, because an increase in kinetic energy, so they spread out because they're moving faster, results or is recorded as an increase in temperature. Then we get to a point where they don't spread out anymore, but I keep putting heat energy into it. Where is that energy going? Well, what it's doing is it's actually breaking the bonds between these particles and allowing them to flow. Now, they don't get very far apart to start with, but they are able to flow. That loses its structure, and that's called melting. The enthalpy change, or energy change here, is positive because bonds are breaking. The bonds between the neighbouring particles are starting to break so that this can flow, which is what makes it a liquid. Once all of the particles have had their bonds broken enough to become a liquid, then we keep heating it. We notice the temperature starts to rise again. So this here would be at the melting point. It's the temperature at which the substance has enough energy to start breaking the bonds between the particles. So between water molecules, not between the hydrogen and the oxygen, but between water and water, between the wax particles, not between the carbons and the hydrogens and the carbons and the carbons. So it starts flowing. Then we get to the point where all of it has melted. And this is where everything is melted. So all of it is a liquid now. If we keep heating, then it starts to expand a bit more, and we sort of see this with our thermometers. Of course, the thermometer rises because the liquid inside is expanding. So as it expands, they're moving faster and faster. We get the same situation. Expansion is happening because the particles have got more kinetic energy. They're moving faster, and we record that increase in kinetic energy as an increase in temperature. We see that happening here. We get to a point where it doesn't increase in temperature anymore, but we're still adding heat energy. And what's happening then is these particles are completely breaking free. So they are becoming particles in the gas phase. They are very spread out, but more importantly, evaporation is happening. The last of any bonds that are holding this in the liquid phase are breaking. And again, the enthalpy change is positive because energy is required to break bonds. And once these bonds between the particles have been broken, they're escaping into the gas phase. Now, once all of the particles have evaporated, and of course this would be at the boiling point, so 100 degrees Celsius for water, whereas melting here would be 0 degrees Celsius for water. When all of the particles have evaporated, then if we've trapped that gas and we keep heating it, then we will actually see a temperature increase again. So you can get water to above 100 degrees so long as you capture it. Of course, with the gas taking up more space, or trying to take up more space, if it's contained, you'll also observe an increase in pressure. So any steam, of course, that can easily be over 100 degrees, if it's contained, will be under pressure because the particles are moving faster and faster and faster because they're expanding, because that's where the energy is going. And of course, we would record this or observe this as an increase in temperature.